as we start to graph lines, we might notice that there are differences between lines. For example, this pink or this magenta line here, it looks steeper than this blue line. And what we'll see is this notion of steepness, how steep a line is, how quickly does it increase or how quickly does it decrease, is a really useful idea in mathematics. So ideally, we'd be able to assign a number to each of these lines or to any line that describes how steep it is, how quickly does it increase or decrease. So what's a reasonable way to do that? What's a reasonable way to assign a number to these lines that describe their steepness? Well, one way to think about it could say, well, how much does a line increase how much does a line increase in the vertical direction for a given increase in the horizontal direction? So let's write this down. So let's say if an increase in vertical for a given increase in horizontal, for a given increase in horizontal. So how could this give us a value? Well, let's look at that magenta line again. And let's just start at an arbitrary point of that magenta line, but I'll start at a point where it's going to be easy for me to figure out what point we're at. So if we were to start right here, and if I were to increase in the horizontal direction by 1, so I move 1 to the right, to get back on the line, how much do I have to increase in the vertical direction? Well, I have to increase in the vertical direction by 2. So at least for this magenta line, it looks like our increase in vertical is 2 whenever we have an increase in 1 in the horizontal direction. And we could, let's see, does that apply? Let's see, does that still work? If I were to start here, instead of increasing the horizontal direction by 1, if I were to increase in the horizontal direction, actually let's increase by 3. So now I've gone plus 3 in the horizontal direction. Then to get back on the line, how much do I have to increase in the vertical direction? I have to increase by 1, 2, 3, 4, 5, 6. I have to increase by 6. So plus 6. So when I increase by 3 in the horizontal direction, I increase by 6 in the vertical. We're just saying, hey, let's just measure how much we increase in vertical for a given increase in horizontal. Well, 2 over 1 is just 2, and that's the same thing as 6 over 3. So no matter where I start on this line, if I increase in the horizontal direction by a given amount, I'm going to increase twice as much in the vertical direction. So this notion of increase in vertical divided by increase in horizontal, this is what mathematicians use to describe the steepness of lines. And this is called the slope. So this is called the slope of a line. And you're probably familiar with the notion of the word slope being used for, say, a ski slope. And that's because a ski slope has a certain inclination. It could have a steep slope or a shallow slope. So slope is a measure for how steep something is. And the convention is we measure the increase in vertical for a given increase in horizontal. So 2 over 1 is equal to 6 over 3 is equal to 2. This is equal to the slope of this magenta line. So slope, so let me write this down. So this slope right over here, the slope of that line is going to be equal to 2. And one way to interpret that, for whatever amount you increase in the horizontal direction, you're going to increase twice as much in the vertical direction. Now, what about this blue line here? What would be the slope of the blue line? Well, let me rewrite another way that you'll typically see the definition of slope. And this is just the convention that mathematicians have defined for slope, but it's a valuable one. What is our change in vertical for a given change in horizontal? And I'll introduce a new notation for you. So change in vertical, and in this coordinate, it's going to be the vertical is our y coordinate, divided by our change in horizontal. And x is our horizontal coordinate in this coordinate plane right over here. And you might say, wait, you said change in, but then you drew this triangle. Well, this triangle, this is the Greek letter delta. And it's a math symbol used to represent change in. So that's delta. And it literally means change in y change in y divided by change in x. Change in x. So if we want to find the slope of the blue line, we just have to say, well, how much does y change for a given change in x? So the slope of the blue line, so let's see. Actually, let me do this. Let me do it this way. Let me have let's just start at some point here. And let's say if my x changes by 2, so my delta x is equal to positive 2, what's my delta y going to be? What's going to be my change in y? Well, if I go to the right by 2 to get back on the line, I have to increase my y by 2. So my change in y is also going to be plus 2. So the slope of this blue line, which is change in y over change in x, we just saw that when our change in x is positive 2, our change in y is also positive 2. So our slope is 2 divided by 2, which is equal to 1, which tells us however much we increase in x, we're going to increase that same amount in y. And you see that. You increase 1 in x, you increase 1 in y. Increase 1 in x, increase 1 in y. From any point on the line, that's going to be true. You increase 3 in x, you're going to increase 3 in y. It's actually true the other way. If you decrease 1 in x, you're going to decrease 1 in y. If you decrease 2 in x, you're going to decrease 2 in y. And that makes sense from the math of it as well. Because if your change in x is negative 2, that's what we did right over here. Our change in x was negative 2. We went 2 back. Then your change in y is going to be negative 2 as well. Your change in y is going to be negative 2. And negative 2 divided by negative 2 is positive 1, which is your slope again.